just now, when it comes to Gaussian elimination method, the idea is very simple, right? Now, let me bring you to what you know. You know, from here, given this system of linear equation, let's say you are just giving this question, I have to solve. You know, with what I know, I can use different methods to solve this. I can use Cramer's rule to solve this. I can use Sarri's method. Whatsoever method I know, I can use to solve this, right? But what if the question says use Gaussian or Gauss-Jordan elimination? How do you go about it? It's very simple, right? And I must say this: by the time you know this method, it is very easier compared to Cramer's rule. You will find this interesting. You get now. Just know that the first task, you know, first thing first, you know, as I've always said, whenever you are given a question, or let me say subtopic generally, you have the steps, right? And the steps remain the same. For any type of question, the steps remain the same. So what it means is that, given this type of question, you also have the steps to implement. Mind you, the steps remain the same. Nothing is changing. Alright, now, first thing first, when you have a question like this, you are going to represent it in a matrix. It is called augmented form of matrix, right? Using the coefficient. From here, this is equation 1, this is equation 2, and this is equation 3. First thing first, you are solving using Gaussian or Gauss-Jordan elimination method. Represent this system of linear equation in your matrix in this format using the coefficient. So it becomes what? Let's do it together. What do you have? 4, -3, -6, 2, 1, -4, 3, -5, 2. Then include these guys too, meaning 8, 3, and 2. Right? But before solving, there's this particular term that is very important. And that term, that's what we use throughout. And it's called pivot. You can take note, pivot. By definition, what does pivot mean? It is a non-zero leading entry in a row. It is a non-zero leading entry in a row. Meaning, this question, you know, this question here, this system of linear equation, you've represented it in a matrix form, right? Call this case 1, call this case 1, and call this case 2. My question is, case 1 and case 2, they are still the same, right? It is still the same. What you just did in case 2 is that you represented case 1 using the coefficient, right? And your interest is just solving the value of x, y, and z. Now, with this guy, this is what you are going to make use of. And this is what we call the pivot. I said by definition, what is pivot? It is the non-zero leading entry in a row. Meaning, you know, this is, of course, this is row 1, this is row 2, and this is what? Row 3. Meaning for row 1, you have pivot. Row 2, you have pivot. Row 3, you have pivot. But the question is, how do I identify this pivot? I said by definition, pivot, it is the non-zero leading entry in a row after row reduction has been done. After row reduction has been done. Meaning before you can identify your pivot, row reduction must have been done. And by row reduction, we are referring to either you've done Gaussian elimination method or Gauss-Jordan elimination method, and that's the topic. Let me just say this: given a question, your first step or the first approach, your final answer, you get Gaussian elimination method. A step further will give you Gauss-Jordan elimination method. There's a similarity between them. What you implemented for Gaussian elimination method, you just go a step further, you get Gauss-Jordan elimination method. So what we are saying is that before you can identify this pivot, row reduction must have been done. And you know the row reduction, we are talking about what? Gaussian elimination method or what? Gauss-Jordan elimination method. Now, for your row reduction, for your Gaussian elimination method, this is it. Take note. For Gaussian elimination method, Gaussian elimination method, you know, this is x, this is y, and this is z. Similarly, this is x, this is y, and this is z. Now, from Gaussian elimination method, after you've performed, say you are given this question and you've performed row reduction, and this is the row reduction you got. So from here, you can get value of x, y, z. How do you interpret? If you check this last row, what does it mean? It means g GZ is equals to what? J, right? Is that correct? From here, let's say these are numbers. A, B, C, D, E, G, they are numbers, right? I'm just using this for illustration. From here, you are interested in knowing the value of X, Y, and Z. Now, given this question, you perform your row reduction. At the end, this is the type of row reduction you got. So from here, you can just come into conclusion by saying X is equals to this, Y is equals to this, and Z is equals to this. Now, how do you do that? Observe, from this last row, you know, this column is for X, this column is for Y, and this column is for Z. Meaning, any entries you have here becomes Z. Or better still, let me say these are the coefficients of Z, coefficients of Y, coefficient of what? X. Meaning from here, you can say that GZ is equals to what? J. That is, GZ is equals to J. Make Z the side of the formula. It becomes what? Z is equals to J over G. Are you getting me? Or to make it easy, let me use numerical values. Let me use values. Let's say from here we have 2. Let me use value. This is 3, this is 4, this is 5, this is 6, this is 1, this is 8, this is 3, this is 2. Right? Now from here, same idea, nothing is changing. From here, I want to get the value of X, value of Y, value of Z, right? From this last tree, meaning that 2Z is equals to what? 2, right? Divide both sides by 2. That is, Z is equals to what? 1. For this last column. Now, move on to the next one. What do you have? 6Y plus Z is equals to what? 3. And we've gotten the value of Z to be 1 here. Substitute. That is, 6Y plus 1 is equals to 3. This becomes 6y is equals to 3 minus 1. Then what do you have? 6y is equals to 2. Divide both sides by 6, meaning that y is equals to what? 1 over 3. Now, you've gotten the value of x and y. How do you get x? Take the whole row 1, meaning 3x plus what? 4y plus what? 5z is equals to what? 8. By the time you substitute the value of z and y, you get x. True or false? True. You get my question? By the time you substitute the value of z and y, just the way we did this, you get what? X. So what this means is that, given this type of question now, you are performing Gaussian elimination method. This is where you are coming back to. This is your focus. Meaning, any type of question given to you, what you want to achieve is that reducing that question. That's what you are saying by row reduction. Row reduction. The rows of that question, you are reducing it to something of this nature. Are you getting my point? Let's say this guy here. Let's say this question now. You know, this is row 1, this is row 2, this is row 3. You've reduced row 3 to something like this. You've reduced row 2 to something like this. And you've reduced row 1. Meaning, you can estimate the value of x, y, and z from here. And that's what Gaussian elimination method is saying. But for Gauss Jordan, looking at this matrix, this augmented form of matrix, automatically you already know the value of x, y, z. True or false? Looking at this augmented form of matrix, let me use numerical values. Looking at this augmented form of matrix, what's the value of x, what's the value of y, what's the value of z? X is what? X is 8, y is what? X is what? 8, y is what? 2, and z is what? 3. Now, can you see the difference between Gaussian elimination method and Gauss Jordan elimination method? What's the difference? The difference is, for Gauss Jordan, looking at a matrix, your reduced matrix, you get the value of x, y, and z directly. No stress, you get it directly. But for Gaussian elimination method, you still perform some algebra. Are you getting my point? Meaning, you have to know the value of z. After knowing the value of z, you substitute, know the value of y. After knowing z and y, substitute, knowing the value of x. Are you getting me? Meaning, depending on the method the lecturer asks us to use, if it is Gaussian, you already have the idea that at the end, your matrix must be reduced to something of this nature. If it is Gauss-Jordan, your matrix must be reduced to something of this nature, and that's it. That's it. That's why I said earlier that Gauss-Jordan is a bit further, having done your Gaussian elimination method. Now let's see, what are the steps? The step you will use to solve this question. What are the steps? Let's see the steps.